Welcome back, pre-algebra students. We're in lesson 4. Today we're going to do a refresher on multiplication and division. So when we multiply, we know that that is just rapid addition. So for instance, if I said 3 plus 3 plus 3 plus 3 plus 3 plus 3 equals 18, that would be correct. That is 3 written or added 6 times. But we also know that I could say 3 times 6 is 18. And that would be correct because this is the same thing as this. I am adding 3 6 times. I also know that I could say 6 plus 6 plus 6 is equal to 18 because I can also say 6 times 3 is 18. I can add 6 3 times and get the same number. That tells me, and that information makes me aware of the fact that it doesn't matter what order we write these two numbers in when we multiply them, the answer will always be the same. And it works very much the same way like addition. It doesn't matter the order, so we give them the same name. Both of these are called factors because they both have the same name, because it doesn't matter what order we put them in. Their position is irrelevant if we are multiplying them against each other. Now, the result of multiplying factors is going to be called the product. So when you have two numbers that are multiplied against each other, the answer is the product. There are a couple of different ways that we can write multiplication, and I want you to be familiar with all of them. Of course, you are familiar with 6 times 3 equals 18. You could also do that on top of each other. 6 times 3 is 18. Then there is the method with the parenthesis where you could say 6 times 3 is 18. This means multiplication. You could even use the dot. The dot is often used for multiplication as well. And the reason the dot is used and the reason the parenthesis is used is because as we get further on into algebra, we're going to start using, just like we did in our addition and subtraction lesson previously in lesson 3, the X can be used, the letters can be used to represent missing information. And sometimes, or a lot of times actually, that letter that we use is an X. And when we use the letter X, we don't want it to get confused with our multiplication sign. So once we start using letters, it's really important that we know the difference, that we don't confuse an X here with the multiplication. So a lot of times we'll switch to the dot or the parenthesis whenever we have an X in the equation as well. So be familiar with the different formats that all mean multiplication, right? It's going to become important later that you're able to identify all of them and use them all interchangeably, okay? So let's talk a little bit about addition. Or not addition, I'm sorry. We did that yesterday. Let's talk about division. With division, it's similar to subtraction. It matters the order that things occur. It matters what you are dividing by, and what the answer is. So because of that, they each have a different name, which tells you where they go in the problem. So for instance, if I were to say 12 divided by 4, I know the answer to that is 3, because I can get 3 sets of 4 out of 12. This number, the first number, the one that we are splitting up or dividing, is called the dividend. And the number that we are dividing it by is called our divisor. The answer that we get once we divide the dividend by the divisor is called the quotient. Completely different letter. So you don't get it mixed up with the other two. There's a couple of different ways to write division. So you could write it like this in a number sentence and use the little division symbol, and that's fine. You can also write it in long division with the box, right? 12 divided by 4. And then this is how you probably learned in elementary. 3 times 4 is 12. Subtract 12 from 12, you get 0. You know you have the final answer here. This is the quotient up here, right? So that's one of the other ways that you can write division. There's another way that you can write division, and it is in fraction form. You can write 12 over 4. That is the same thing as saying 12 divided by 4, and the answer would be 3. And this would be your dividend over the divisor. And then this answer here is, of course, the quotient. If this kind of not triggers a little memory, but if it reminds you of fractions, it is a fraction. That is what a fraction is. A fraction is a division problem waiting to happen. It's waiting to be solved, right? That is 100% what a fraction is. So here we have 12 over 4, which equals a whole number, but if you had another type of fraction, 1 divided by 4, that's 1/4 of something. We're taking one thing and dividing it into 4 pieces. So you can see how that a fraction is actually a division problem when you look at it like this and like this side by side. All right, so let's do a couple of problems and work through them and refresh our memory and renew our skills just a little bit. So let's do a multiplication problem first. Let's multiply in problem 4.1. Let's do 164 times 23 and find the answer to that. So one of the easiest ways to do multiplication is to stack it. So if we stack it like this, we can multiply and say, we do our ones place first. So 3 times 4 is 12, carry the 1. 3 times 6 is 18, plus 1, that's 19. Carry the 1. 3 times 1 is 3, plus 1 is 4. Right now, we're moving to the tens place. To remind us to move over, I like to put a 0 right there, because I'm not using the 3. I'm not in the ones place. I am now in the tens place. So technically what I'm doing is multiplying 20 times 4. But because it's such a big number, it's just easier to take the 10 out and put that 0 as a placeholder here. So now I can go back to saying it's 2. 2 times 4 is 8. But if you think about it, 20 times 4 is 80. So isn't that the right answer anyway? It is. So now let's do the rest of it. 2 times 6, that would be 12. I'll carry my 1 again. 2 times 1 is 2, plus 1 is 3. Now I can add everything straight down. 2, 7, carry 1, 7, and 3. And my answer should be 3,772, and it is. But I like to use the placeholder. And if you'd had a third number here, then you'd put 2 zeros on the next line, just to give you that additional boost, so you get everything in the right location because of place value. Where it is matters. And this has a value of a tens place, so we needed to start putting our answer in the tens place. So let's look at a division problem. Let's try one of those. We'll refresh our memory with this one. 2,000, this is problem 4.4. 2,183 divided by 47. All right, so let's put that in a long division block. Here's our dividend, 2183. And here is our divisor. That's correct for those of you who are filling in and waiting for me to say it. So what I'm going to do is I'm going to look at the number of digits here and the number of digits here. I've got 2 digits here. Look at the first 2 digits here. Well, 47 is greater than these first 2 digits. So that means I can't divide it out of these two. So I'm going to have to go to the first 3 digits. So 47 is close to 50, right? If I round up using the skills we learned in lesson 2. If I round up, that's about 50. And I know that 100 has 2 50s in it. And there's 200 here. So I am going to say I've got 4. So 4, yeah, that sounds about right. I'm going to use 4 as this number. I'm guesstimating. So now I'm going to do my multiplication and see if I'm right. 4 times 7 is 28. So 8, carry the 2. 4 times 4 is 16, 17, 18. So I'm going to write the 18 here. All right, now let me subtract. And as long as I have less than 47, then this number is big enough. So 8 minus 8 is 0. And I'm going to have to borrow to make this 11. And this will be 1. 11 minus 8 is 3. And 1 minus 1 is 0. So 30 is less than 47. So this is the right number here. Okay, so now I'm going to bring down my 3. And I'm going to do the same thing. I'm going to guesstimate close to 50. And I've got 300 here. So that's going to be 6. So if I say 6 times 7, that is going to be 42. So I'm going to write 2. And I'm going to carry my 4. And 6 times 4 is 24 plus 4. That's going to be 28. So then when I do my subtraction to see if I got the right number, I'm going to borrow here. And that is going to be 10. And this is going to be 2. So 3 minus 2 is 1. 10 minus 8 is 2. 2 minus 2 is 0. So I have 46 with a remainder of 21. All right. Now another way that you can write this, because we know that a fraction is a division problem, we have this remainder of 21. It still needs to be actively divided by 47. So if you write 46 and 21 over 47, that is just as correct as this is, believe it or not. So let us, you can answer it this way, or you can answer it this way on your practice problems. So now let's practice trying to find the missing number in multiplication and division, now that we've refreshed our memory. So if I want to find within a multiplication problem a missing number, let's say I have, let's do problem 4.6. Let's say I have 5 times 3. I just gave the problem away, didn't I? Let's do another one. Let's do 4 times b is equal to 20. The thing that you're going to do here is you are going to turn these factors into parts of a division problem. We are going to do the inverse operation, just like we did for the addition and subtraction. We're going to do the inverse operation. So the product becomes the dividend. So it becomes the number that we're divising. We turn it from a multiplication problem into a division problem, and we put it in the long box. So first of all, the product becomes the dividend. And we know the product is here, so that we put that in the box. And then the factor that we know becomes the divisor. All right, so that's the other thing. The known factor equals the divisor. So then this would be 4. That would be our divisor. And then the unknown number would be equal to the quotient. And then that quotient would become the factor that comes back in and fills our missing information. So 4 into 20 we know is 5, because 5 times 4 is 20. And that would be our answer. So B would be equal to 5. So we could check that by just saying 4 times 5 we know is equal to 20. So we know that we got the right answer for B. B is equal to 5, right? So that is what you would do when you have a multiplication problem and one of the factors is unknown, okay? And it could work for either one. It could have been this factor that we knew and we didn't know this factor. Whichever factor you know becomes the divisor and the other one becomes the quotient that you can then put back into the sentence and check it. So let's see what happens when there's an unknown in a division problem. So here we have one. We have 64 divided by A is equal to 4. So to find the missing divisor, we divide the dividend by the quotient. So it flips on us. So what happens is the dividend remains the same, but we exchange the quotient for the divisor, right? So the dividend remains, just like in the other subtraction problem, the minuend stayed the same. The dividend here stays the same. So the dividend remains, and then the quotient and the divisor change places. So what we have is 64 now becomes divided by 4, and that's going to give us what A is. And we can do that using long division. 64 divided by 4, 6 divided by 4, that's 1 time. Remainder of 2, bring down the 4. 24 divided by 4 is going to be 6. 6 times 4 is 24. And that is our answer. So if we now sub this back in, this is our answer A. We sub this back in, 64 divided by 16 is equal to 4. And we can very easily check that by multiplying 4 times 16 to see if it is equal to 64. What happens if the thing that's missing is not one of these, right? It's not the divisor. What if the dividend is what's missing? Let's try one of those. And that would be problem 4.7. We have B divided by 3 is equal to 15. So what happens here is we switch over to multiplication. So the quotient and the divisor become factors. And then the unknown dividend is the product. So all we do is we switch this around and say 15 times 3 is equal to B. So now we know that B is 45. And then we check it. We can put B, 45, back into B and say, is 45 divided by 3 15? Well, let's see. 45, 3 into 4 is 1. 4 minus 3 is 1. We bring down the 15. 3 into 15, we know that's 5. 5 times 3 is 15. So yes, 45 divided by 3 is 15. And we got there by using the inverse operation of multiplication because we did not know what the dividend was. When you don't know the dividend, you turn it back into, or not back into, but you turn it into a multiplication problem by multiplying the quotient and divisor together to get the original problem or the original dividend. All right, so write down your steps as we come across them. That's all we have for lesson 4. I will see you in lesson 5.